50 times 2 is 100. Who else did it Jose's way? No, we've got some different ways out there. I want you to turn and talk for a second. Why do you think Jose chose to do 10 times 5, and why he didn't just go in order like that? Why did he choose to do 10 times 5? Okay, so come back to me. Let's talk about this. Jose didn't just go straight through the problem. He went and did these problems, or these two first. Why do you think Jose chose to do 10 times 5 first? What do you think, honey?
But I think he chose to do these ones first because, well, you know that 50 plus 50 equals 100, and it's basically doing that when you times it by 2.
Oh, yeah. So when we times 2, what do we call that? When you do 50 and 50?
Multiplication.
It is multiplication. You know when you do times 2?
It's
Doubles. That's right. So they're doubling that 50. So, Jose, is that kind of what you were thinking? You wanted to do 50 first? Is that why you did that one first? You're like, who else thinks they know why he did that? That he knew it was a double. You thought it was what?
Because it may have been easier for him.
Oh, Jose, was it a little easier to do in your head? Really quick? So we had a bunch of people agreed with Jose that they did it the same way. Did anybody do this problem in a different way that they solved it though and got 100? Tell me your name, honey.
Joshua.
Joshua. Joshua, what did you do?
I did 2 times 5 equals 10.
Okay. You did 2. Oh, hang on. He did 2. Wait a minute. You're like, can you do this? He's moving numbers around. He put the 2 and 5 over here together. Can you do that?
Yes.
Really?
Yes.
Yeah, so you can just move numbers around. Look at what he's doing here. He did 2 times 5 equals 10. Turn and talk. Why do you think he chose to do that first?
And then 10 times 2 is 10. She could like 5, 10, and then 2 was 10.
Alright, so come back with me. What do you think about Joshua here? Why do you think he didn't move those numbers around and put the 2 and 5 together? What do you think?
It's a known fact that
Kind of a known fact.
is 100.
Yeah, so maybe, Joshua, did you just know that 10 times 10 is 100? And so that made it a little easier for you to do. So you guys like moving numbers around and regrouping them together to make it a little easier. So let's try another problem. Are you ready? Let's try another problem. So I think we proved that was 100. Here we go. Have a look at that one. When you have, a strategy, you gotta watch this level, I'm clumsy. So when you're done thinking, okay, looks like most of my thumbs are up, which tells me you're kind of done thinking. But before we share our product this time, I want you to turn and talk to your neighbor again. Here's what I want you to talk about. I want you to talk about what's the product, okay? And how did you solve it? And the person with the longest hair goes first. Good luck, boys. Figuring that out. Okay, yeah, I know you got it. All right, let's hear it. What'd you get? How'd you get it? Anybody else? You did.
No, that's tall. No, look, my hand's
Use what you did. Alright, so let's come back together. You guys are really excellent at turning and talking. I love it. So let's talk about the product first. So you guys had all kinds of strategies over here. So what did we get as the product? What did you get, honey?
100.
Got 100 again? Did anybody's group get a different answer? We all agree it's 100? We all agree? 100. I see y'all doing this. Me too, I agree. So let's talk strategies here. I heard several of them out there. Who wants to share some strategies that you and your partners talk about? Tell me your name, sweetie.
Zach.
Zach with a K?
With the H.
Oh, an H. See, always gotta ask. All right, Zach, tell us about your strategies that you and your partners talked about.
5 times 5 equals 25.
Oh, so he did 5 times 5 is 25 first. Let's think about that for a second. Wonder what he was thinking in order to do that. Why would he? Did anybody else do it this way? And do 25 first?
No.
Yeah.
No? So why do you think that Zach would want to make 25s first? What do you think he was thinking? Turn and talk to your neighbor. What do you think? Why would he do that? Same way, did you did it? You think you would you mind sharing that? Would you mind sharing that? That's
Probably
okay.
break it apart.
Maybe it's because
All right, let's come back together. And tell me your name, sweetheart. Jacoby was talking about what he thinks Zach's thinking here. Jacoby, you want to share what you said you did or you were thinking?
So if you didn't know what 4 times 25, you say it's like 4 quarters equals 100. So 4 times 25 is 100 because I knew that fact in my head.
So 4 quarters are equaling 100. How does that help here? How is Jacoby kind of using? How's he using that to help him solve the problem there? Yeah.
Because maybe he knows that quarters are worth 25 cents, and then if you do 25 plus 25 times 2 equals 50, and then do that once again, and you'll get 100. And then Zach only took those 4 quarters and put them right there.
Yeah.
And he got how much the quarters.
So tell me your name, honey.
Kinley.
Kinley is saying that she was doing like 2 25s. Repeated addition. I know Jacoby was talking about that he might be able to do 25 plus 25 plus 25 plus 25 because he was saying that was repeated addition. There were 4 quarters and $1 is what he was telling me over there, so he knew that. But then, wait a minute, Kinley is saying that she might have used 2 groups of 25. So let's go back to this. She said she might have used 2 groups of 25. I want you to turn and talk one more time. If she's getting 2 groups of 25, where's the 2 coming from? What is she doing? Turn and talk to me. Okay, so come back to me. If Kinley, is it Kinleeey? Okay, I never spell it right. Kinleigh. So Kinley is saying that she took 2 25. Somebody, you guys were talking about it. Who wants to share where she got this 2 from? What do you think?
She got the 2 because she took Zachary's 4. And decomposed it into 2.
Okay.
Times 2.
2 times 2.
And she took one of the 2's and she did 25 times 2, which is like 2 quarters. And
Okay.
that would be 50. And then she took the same and did 50.
Oh, so then she's taking 2 times 25 and 2 times 25, right? To get the 2 groups of 25?
Yes.
So let's think about that. So if I'm doing 2 times 25 on each of these, what have I got to do to both of these products?
You have to add.
Yeah, I got to, who said it? You said add? Add them together. So I'm going to have to add them together. So look back at this problem. Did we decompose this correct way? So we had 50 plus 50, right? To get our 100. So 2 25s and 2 25s. What do you think? Should this be a times? Or should it be that addition? Should I have decomposed that into factors or into add-ins? Turn and talk. What do you think? And why do you think so?
I mean, it's a double.
Should have been in the factors or should have been in the add-ins? Timer's going off. Got another minute or so.
It's 2 and you got 2 veggies and that's like 2.
Interesting. Alright, so what do y'all think? So I decomposed it into the factors. We said it could be 2 times 2. We can definitely decompose it into its factors, but then we added these together. So what do you think? Did this need to be multiplication or did it need to be addition? What do you think, sweetie?
It needs to be multiplication.
Why?
Because if it was addition, it would have to be 2 plus 25 plus 2 plus 25, which would give us 27 and 27, which is not 100.
So So let's look at that. So 2 plus 2, if I decompose that 4 into 2 plus 2 or 2 times 2, and thinking about how we got these 50. So what did you do with these numbers? How many 2's do we have here? 2. How many 2's do we have here? 2. So they both equal 4. Do y'all agree with that?
Yes,
So what are you thinking though? If we're going to add these pieces together, these partial products that you guys are getting, where I'm hearing a reason that we need to do 2 times 2 because you said if you added them together you would get 27. Is that what you said?
Well, like if you added 2 plus 25, it
Oh.
would get 27, and then add to 2 plus 25 again is 27 plus 27.
Yeah. So if I was putting the 2 plus the 25, but am I doing the 2 plus the 25 or the 2 times the 25? Did anybody think that I need to put them as addition? Everybody thinks we need to have multiplication? Yes. So let's talk about how we got this add then. How did this get here? Where did that come from? So why did I add these 2 partial products together? So where am I getting this 2 and 25? Okay, so I took 2 times 25 is what you're saying? So I took this 2 and multiplied it by the 25?
Yes, ma'am.
And if I took this 2 and multiplied it by the 25, why am I adding them together? What do you think?
Because you can't have 2 answers. You want to add both of them together because you split your 4 in half, and so you have to do both of them and then add them both together.
Yeah, so you said something there. You said you split them 4 in half, and then I had to add the 2 partial products together. So if you're looking at taking this 25, this 2 times 25, and then I'm adding it to this 2 times 25 to get my 2 partial products of 50. So if I'm going to add them together when I get through with them after I distribute, this is called the distributive property. You guys probably have talked about that some, right? So I'm distributing those out. So we're looking at adding them together because if we're multiplying them together, it would be multiplying straight across. This would end up being our 4 times 25 again, right? So we'd end up with that same problem. So let's think about that. I'm going to have you guys talk about that some more in some of your number talks, but I want you to look at this last problem real quick to see if you see anything that is the same or different about this last problem. Look at that last problem there. Think about the answer. So here's what I want you to think about because your fingers went up super quick, your thumbs. Where do you see these problems in this problem? Where do you see these problems that we did earlier in this problem? And how did these problems help us solve this one? Try to talk to your neighbor. Where do you see that problem? These problems in that one.
In there, right?
Okay, so let's come back together. Would you mind sharing your idea that you talked about back here? What you saw? Would you tell me your name? Patience. Patience, would you tell us kind of what you noticed about Zach and Jose's problem when they were doing? What did you notice?
I said that it was 5 times 4.
So there was a 20 in this problem. Did y'all notice that? Did you talk about that in your groups? Did you see anything else? What about this problem? Yeah.
You can 2 times 10 equals 20.
So you saw a 20 in this problem as well. I wonder how these problems help us solve a problem like this. What are you thinking?
Because when you get